Okay, hi everybody. So consider this sequence where we've picked some positive real number that's strictly greater than 1. And so the x sub n's are actually real numbers. And so we can make meaningful the statement that the x sub n's go to infinity. Okay, we might say this, go to infinity. And that's what we might say in words, but what do we really mean by this? What we mean is, proof. Remember that for a real sequence, x sub n goes to infinity means, what does it mean precisely? That for any positive number, there exists a cutoff such that going past that cutoff implies that the x sub n's are greater than that number. So this is what it means to go to, I guess, positive infinity. I didn't put minus infinity. It means that for any really big number, potentially really big number, if we go far enough out in the sequence, then those sequence values, in fact, all of them past the cutoff, will be strictly bigger than no matter what number you pick. So as big as you like, all of the x sub n's will be greater than that. Okay, so okay, so proof, it starts by just me reminding the reader, what does this even mean? Okay, so let B be given, B meaning a positive number. We need to find n. Can we find an n such that this is true? Everything past that capital N is bigger than B. Okay, and this is not clear how to do this, but here's the insight. It really matters that C is strictly bigger than 1. If we're on the number line, here's negative 1 and 1, C is like somewhere over here. Okay, maybe that is C. But that means that C is equal to 1 plus a positive number. Let's call this epsilon slash epsilon. This is actually different than the in symbol. There's two different symbols. This is slash in, this is slash epsilon. So I'm going to write that in my proof. Since C is strictly bigger than 1, then we can rewrite it. Rewrite C equals 1 plus epsilon for some epsilon strictly positive. Okay? Now, why would we want to do that? So now I'm going to go to some calculations. Let's go do some calculations with this number. Remember, our sequence is C to the n. So we need to take this to the n. Okay, well, 1 plus epsilon squared is 1 plus 2 epsilon plus epsilon squared. 1 plus epsilon to the third is 1 plus 3 epsilon plus 3 epsilon squared plus epsilon to the third. 1 plus epsilon to the fourth is 1 plus 4 epsilon plus something else. And 1 plus epsilon to the nth power will be 1 plus n epsilon plus some other things, n choose 2 epsilon squared, n choose 3 epsilon to the third, plus plus eventually epsilon to the n. And what we notice here is that because epsilon is positive, these are all positive. because epsilon is positive. So what that means is that 1 plus epsilon to the n is actually bigger than 1 plus n epsilon. Why? Because if you start with 1 plus 1 n epsilon, you have to add a positive number to reach this number. So this is true. Okay. All right, so that was my sort of important calculations. Now, what does this mean? Well, let B be given. It's kind of clear that we can find, we can find capital N so that 1 plus capital N epsilon is bigger than whatever B. So no matter what capital B was chosen, we can find a capital N so that this is bigger than B. But then, if little n is bigger than capital N, then 1 plus n epsilon, well, will be bigger than 1 plus capital N epsilon, which is bigger than B. So this is bigger than B, too. And that's it. We're done. That is what we needed to prove. Well, okay, let me say, sorry, we're not completely done. But by star, we have x to the n, which is 1 plus epsilon to the n, because it's c to the n, is greater than b, too. And that actually finishes the proof. So this is a little tricky. The key here was to rewrite, since we knew that c was greater than 1, write it as 1 plus epsilon, and then use our knowledge of Pascal's triangle. Try to test yourself on this one. See if you can, blank sheet of paper, prove this without looking at the video.